Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. For hot, arid, and semi-arid environments, this is section 2, landforms. So for the landforms, we need to look into a couple of processes first and then go into the different types. So the sources of energy in the desert then, it still goes through the similar processes as other landforms: weathering, erosion, transportation, deposition being primary ones, and the combination of a few of these processes then can cause mass movement. Insolation, the high solar energy, definitely has a significant impact. We can see in these latitudes, it receives a high amount of incoming solar radiation, as we mentioned in section 1, and this can cause also major daytime and nighttime temperature difference. Because it's mainly rock, sand, and this type of surface being heated up, it tends to have a very low specific heat capacity. So this means that things like rock can heat up very fast. Think about if you've ever been to a very warm beach and how the sand can kind of burn your feet in the day if it's really, really high temperatures, but then at night you can walk on the sand no problem. And this is because the temperature has fluctuated. So the ground tends to heat up very fast, but it tends to cool down very fast as well. On the other side of that, it means that the air then moves away as well from the area. So this means that the heating during the day, all that heat rises directly up until there's no more. And when the sun sets, as in after the sun sets, there's no more incoming solar radiation, but the heat continues to leave the ground then until it's gone. This means that the temperatures can plunge at nighttime. Now, in other climate zones, they might have more cloud cover to re-radiate that heat back down, but there's limited amount of clouds in this area. So this causes then the air to move away from the area and not to get re-radiated back down. So basically, it has no insulation. With the wind, then, we see the trade winds are in operation here. This goes back to our Hadley cell diagram in the first unit, if you want to go back and take a look at that. This is sending air from an area of high pressure to an area of low pressure. So this means air is going from an area of the desert and it's going back towards the lower latitudes, down towards 0 degrees or the ITCZ. So this creates then local winds that could be quite strong, and this creates then aeolian transportation and the potential then for wind erosion as well. So creating things like dust storms, sandstorms, but just in general then being able to cause wind to move as it picks it up. Runoff then is associated with the precipitation. We can have different types and we can see this over different periods. So for example, we have the intense rainfall that can cause then episodic rainfall, and this idea is that it's just going to be for a short period of time. This can create then storms, rivers, and runoff then can form. So there's not going to be as much soil or as trees to absorb the precipitation when it comes. And we can see then a profound impact on the water that does actually go through those areas. So there's the three major sources there of energy and changes to the landforms there as well. The sediment dynamics then, looking at input, movement, storage in this material, we can see weathering, aeolian transportation with wind, fluvial processes with water, and even glacial influence in some regions as well will cause sediment to be brought into the system, broken down. This creates an area then where the sediment cell, it causes erosion, or weathering in one section will cause transportation into another and create deposition and features of deposition. So there's a balance between the three. Now, if it's in a positive sediment budget, this means that there is more material is deposited than removed. And we can see the negative sediment budget, that there is material lost through deflation or runoff that is replenished. So basically in one section we can see the building. In a positive sediment budget we can see the building up of some depositional features. In a negative sediment budget we can see the removal and the deflation or the reduction of some of the landforms and features. So let's talk about the different types of weathering that we expect to find here. Insolation weathering or thermal fracturing then is found where we have the extreme variations between night and day. As I said before, the rock is definitely going to heat up with the specific heat capacity being quite low, which means that it changes temperature quite easily. But realistically, it mostly happens on the outside of the rock. Because it doesn't penetrate, or the heat doesn't penetrate down much through the rock, this causes the outside then to be expanding during the day and to be contracting during the night. This means that it's going to be forced to crack open into little pieces like we can see here, fragmented. Now obviously the one below is not in a typical arid area, but it just shows you the concept of exfoliation there in this case, so that it can break off into little pieces and naturally just fall off. This is disintegration. It's a physical weathering therefore, and happens quite a lot in arid deserts because of the diurnal difference. Here we can see the exfoliation happening of the rock, and we can see it as a spheroidal and round kind of process that's happening here. Thin layers then being